Hey guys, I'm John and welcome to Respect Your Intellect. I'll be answering a few more of your awesome questions today in this third video of the series, so don't forget to hit the like and subscribe buttons and let's get started. The first question comes from De Louvre, who asks what the life cycle is of a star from the birth in the nursery to the death as a supernova. So to start off, stars form from gas and dust floating around in nebulae. Some areas will be more dense and will start to attract more dust and gas through its gravitational pull. This continues until the star forms enough pressure inside to start fusing atoms together and start its life of shining brightly. The size of the resulting star will determine its lifespan, its color, and its temperature. It's at this point that we pretty much split the types of stars into two types, the average stars and the massive stars. For the average stars, the smaller they are, the longer they'll live because they burn through their fuel much more slowly than bigger stars. Average stars can shine for several billion years. For the massive stars, they'll burn through their fuel much more rapidly, and some of these stars only last a few 100,000 years before they exhaust all of their fuel. When these two types of stars are finished exhausting their fuel, they start dying and grow into red giants. Average stars become red giants and massive stars become red supergiants. At this point, the average stars have relatively peaceful and beautiful deaths as they eject their outer layers and become planetary nebulae with a white dwarf in the center. These white dwarfs eventually cool and dim over time, leaving a brown dwarf. Massive stars, on the other hand, are extremely energetic and their deaths are anything but peaceful. The death of massive stars are supernovae and they're extremely violent. These supernovae, like the average stars, leave behind a remnant of the supernova that depends on the original size of the star. The most massive ones leave behind a black hole, while the less massive ones leave behind a neutron star. Since neutron stars are very small, the energy from the original star and the explosion usually results in an extremely rapid spin on the neutron star. So from this point after the star's death, the remnant left over will slowly lose energy over time and become dimmer and colder. The only thing that can put energy back in is interactions with other objects. So I hope that answers your question, De Louvre. The next question comes from Omni, who asks what is spacetime and mentions quantum foam, zero-point energy, and the Casimir effect. So for this question, I'll only address the spacetime because I don't know the other three deeply enough to form an educated response without heavy research. As far as spacetime goes, we were always aware of the three dimensions we experience, as well as the linear time we experience as we live our lives. What spacetime is simply a merging of those two things into a four-dimensional continuum, where time is not a constant. This gives us a framework where time is experienced differently depending on your velocity through space. The slower you travel, the faster time ticks. The faster you travel, the slower time ticks. And at the speed of light, time stops completely. This knowledge of spacetime allows us to explain why different observers experience the when and where events differently from each other. So even though my answer to your question doesn't cover everything you asked, I still hope it helped you or someone else watching. Next we have Demonic Davros that asks how dark matter and dark energy affects our sun, planets, and moons, and also asks if it's the reason for the asteroid belt and Kuiper belt. So dark energy wouldn't have anything to do with our solar system in itself. Dark energy is what's responsible for the accelerating expansion of the universe, and its effects are only noticed across extremely large distances. For things that are closer together, there's just not enough space in between to expand and have an impact. So as for dark matter, it also doesn't really affect things over short distances. The way we know it exists is by the fact that if we account for all the visible matter in the largest structures in space like galaxies and clusters of galaxies, there's just not enough matter to hold these structures together. So dark matter has to exist to keep things held together. Over short distances like our solar system, dark matter wouldn't play much of a role there since the movements and behaviors are determined by the visible matter. Dark matter is only responsible for our sun's position within our Milky Way galaxy. Now for the asteroid belt, it's a disk of asteroids between the orbits of Mars and Jupiter that we can currently only hypothesize as to how it formed. What we think is that this region was too heavily perturbed by Jupiter's gravity to be able to combine and form a planet. So instead they just continued to orbit the sun as they've always done. In essence, the collisions were too energetic to clump together without exploding and fragmenting at the same time. The Kuiper belt is the same type of disk as the asteroid belt, but 20 times as wide and up to 200 times as massive in the outer solar system, beyond the orbit of Neptune. Like the asteroid belt, it's hypothesized that due to the perturbations of other planets like Neptune and Jupiter, that they simply failed to coalesce into another planet and formed smaller bodies instead. In all of these cases though, it's safe to say that neither dark energy nor dark matter had any noticeable effect on our solar system, other than the fact that our Milky Way galaxy and therefore the position of our sun is held together by dark matter. Any other effect is greatly overpowered by the visible mass in the solar system. I hope this answers your question, Davros. Next we have I Can Science that asks if gravity is a force and also mentions that we get different answers from different physicists about it. So this is a pretty good question because we don't have a completely clear answer to that yet. Newton introduced gravity as a force that had an instantaneous effect on all other bodies in the universe instantly. Einstein came later and showed that there is no instantaneous effect across distances, and it instead propagates through space as a gravitational wave that travels at the speed of light. With our current understanding, we know exactly how things behave and move with their gravitational effects, including light that has no mass. What allows us to make these extremely precise calculations and predictions is by establishing the geometry of space that curves around massive objects. So at this point, we know exactly how gravity works, and it allows us to calculate an incredible amount of things like orbits, landers, probes, eclipses, etc. But we can't answer yet what the nature of gravity is or why it exists. In order to be able to do this, we'll need to reconciliate general relativity with quantum mechanics under a single theory of quantum gravity, so that the force of gravity can be explained in quantum mechanics like the other three fundamental forces. Until then, you might continue to get some different explanations from physicists, but they all generally mean the same thing, that space is a fabric that bends around massive objects, and other massive objects follow that curved geometry. Whether you choose to call it a force or the geometry of space doesn't really affect the outcome, it's just how you prefer to see it. I generally call it a force, and when I'm asked to explain further, it's only then that I start talking about the curved geometry of spacetime. I know this doesn't completely eliminate the confusion, but I hope it helps you anyway. That's where I'll stop for this video, so if you have any other science questions for me, don't hesitate to ask in the comments. I'll also remind you that my Discord server is also currently open to the public, and this would also be a good place for you guys to come ask your questions. So if you're interested, check the description for the invite link. If you want to follow along or be a participant of this series and get answers to your science questions, make sure to subscribe to the channel and click the bell notification to be notified of all my uploads. You can also check out my website at respectyourintellect.com for all the information on this channel. Until next time, thanks for watching, and remember, respect your intellect.